This is nothing more than a continuation of what we would call basic wiring. It just happens to have its focus to the outside this time and not indoor. If you want to pass these around and take a copy. What is the difference between indoor and outdoor wiring? Does anybody have a good idea?
Well, indoor is probably simpler, outdoor is harder.
No, it's the same. It's exactly the same. Your indoor wiring and your outdoor wiring. If you're wiring a light fixture, okay, you have an outdoor light fixture as opposed to an indoor light fixture. It's the same. There's no difference. It just happens to be that the outdoor equipment is rated for outdoor and not indoor. Can you use an outdoor fixture indoor? Sure you can. Because it's rated outdoor, that makes it even safer indoor. But the wiring is the same. There's really no basic difference until you're getting to underground stuff. So, again, let's take some basics. We're mainly going to be dealing with lighting and switching and power outside, but I'll go through a couple basics that deal with outdoor first. Number one, if we're running underground cable, let's say from your house to your garage, you have a couple options. You have outdoor cable itself that can be buried. You have PVC piping that can be buried. Remember, I'm saying it can be buried now. This is not for exposed work. It's PVC, not metallic, at least in Chicago. And the difference between a heavy wall pipe and conduit is obvious. You're not going to be burying conduit in the ground. It probably wouldn't last 10 years underground, and you'd have to redo it. So we're really dealing with the heavy wall piping with threads on it and threaded connectors and everything else. Those are your underground options. Depending upon where you, in effect, are doing your wiring, whether it's in Cook County, Chicago has its own code in the United States. If you're dealing up in Wisconsin or Michigan or somewhere else in Illinois outside of Cook County, you really have to know the codes on what you're doing. It's always good to ask questions of somebody that knows what they're doing before you begin. You'll notice I have passed around some testing sheets, and I don't think we got the electrical tool kits. If you're going to be doing wiring, we want to be able to do it safe, is the primary goal. You have to be able to use and understand certain type of test equipment. If you're not familiar with the equipment, you should read up on it, know how to use it. And what is the first thing we always want to do when we're working on an electrical circuit?
Make sure the power's off.
There you go. Make sure the power is off. When you're working outside, consider yourself always grounded. Inside, I'm wearing rubber shoes. I'm on a wood floor. Normally, I'm not grounded unless I touch a metal pipe. If you're working in wet grass, or maybe there's a little water on the cement where you're working, guess what? You're grounded. Okay, so it's always a better safety feature when you're working outside to make sure the power is off. If you're working on a problem and you need the power on to run your test equipment to find out where the problem is, that's one thing. Okay, that you have to sometimes do hot. But once you find where the problem is, it's better to shut that circuit off so you can work on it safely. There's really not many excuses to work hot. I mean, even here in the store where we've got computer equipment, I have a dozen registers and computers. It's not going to hurt for one of those registers or computers to go down for 30 minutes while I'm working on the circuit. There's plenty of overlap here. So unless it's something extremely critical like in hospitals and whatnot, there's really no reason to work hot. Just shut the circuit off so you can work safe. All right, we've gone through some of the outdoor stuff. If in fact you have to run surface conduit, again, Chicago has its own requirements, and that is heavy wall metallic. You will see conduit run on the surface, the thin wall. They even have water-resistant fittings, but in Chicago, it's not code. So when you're dealing with surface-mounted conduits, it has to be heavy wall or intermediate wall metallic. You can also run aluminum, although we don't really stock the aluminum, but we can special order it for you. PVC is underground. Seal Tight is like Greenfield, except it has a rubberized coating on it. It can also be used underground, and it can be used above ground for signage, maximum a 6-foot whip. It's a flexible, rubberized, metallic conduit, waterproof, exposed, maximum 6 feet. Your normal wiring, again, I said indoor and outdoor wiring is probably very similar. Again, it's normal 14 or 12 gauge wiring that is going to be used for wiring outdoors. There's no difference between that and your indoor wiring. Whether you use stranded and or the solid wiring like I have here. One of the differences you'll see, though, is that especially if you're working with either the Romex or the plastic pipe, is you're running a ground wire, a green wire. Or the Romex itself, the underground stuff, has its own bare ground wire because there's no metallic sheathing here. So you have to run a ground wire. That's your only addition between inside and outside. Again, the main difference between indoor and outdoor is the rating of the equipment itself. You'll notice that the boxes are outdoor rated. They have threads in them so that you'll have a positive water seal when you screw your pipe connectors into them. All right. They can be totally sealed up. There's multiple holes, but they give you threaded caps. You block off the holes you don't use. The covers, again, are threaded, plus they're gasketed, so when you screw the cover on, there's a gasket under it that seals out moisture and water. Again, it's a metallic box, same as inside, except it's rated outdoor. Same thing with, your power boxes. They're all threaded, come in different colors. Your main colors being gray, white, and brown. So you do have a couple color choices, and black also. Some companies will give you black. When you're dealing with switches, there's really no difference. If you're putting a switch outside, you'll be using an outdoor cover to cover it, but it will be accessible. It's just a switch, same thing as you would use inside. Just a standard, ordinary switch. When we're dealing with the power that would go into an outdoor box, okay, now we have not only Chicago requirements, but the National Electric Code, and that means just about everybody else is caught up with Chicago. It used to be only Chicago had the ratings. Now, if you have an outdoor fixture with power in it, they want you to have a GFI in that outlet. Okay? If it's outdoor, it's GFI protected. Remember, we're dealing with water, we're dealing with moisture. Consider yourself grounded at all times and the equipment you're using. So a GFI will not only protect your equipment, will protect you. It helps protect the wiring itself. So all outlets outside must be GFI protected. Do you have to use a GFI? Not necessarily. There is such a thing as a GFI breaker. Okay, this can go right into the circuit box that outdoor wiring is connected to. You don't necessarily have to use a GFI outside because sooner or later the moisture will get to these and they're going to have to be replaced. This is all inside in your circuit breaker box. If you have fuses, you'd have to run a secondary box. They don't make GFI fuses, but just about every breaker manufacturer does make GFI breakers, and that will protect all your wiring outside also. Again, switching is your normal switch. Do you have to GFI protect your outdoor lights? No, it's not power. Can you? Of course. There's no reason why you have to. If you want to, you can, okay? But you don't necessarily GFI protect your light fixtures itself. The differences between indoor lighting and outdoor lighting, again, it's outdoor rated. Waterproof fixtures are all fixtures that go outside waterproof? No. But they are built, if you have decorative lighting, this fixture is not waterproof, but it's designed to direct water away from the electric. And it's built like with solid brass, so it's not going to rust out. So the fixtures themselves are rated outdoor. They're specially built to direct water away from the wiring. Can you also use gaskets under them and things like that? Sure. But the fixtures themselves are rated outdoor. It's the only difference between an indoor light and an outdoor light. Controlling outdoor lighting. There's many methods of control. Just as with an indoor light, you could have a switch either inside or outside. Obviously outside it's protected in a waterproof box. Inside doesn't matter. A lot of garages, if they're separate garages, will have a switch inside the house and inside the garage. So they work three ways. You can turn them inside, turn them on before you get to the garage, turn them off as you're leaving the garage. Doesn't matter. That's three-way circuitry. I'm not really going to get into that. We're just dealing with basic wiring today and basic construction outdoor. If you've seen my basic classes, I deal with single pole switches and three-way switches and things like that. Another method of controlling lighting outdoors is either photocell or motion. Photocells can be extremely simple, where they can actually screw into where you're going to put your lights. A lot of fixtures come with the motion head already on them. You've seen the security lighting. It's very common, and all the fixtures already come with a motion head already assembled on the cap. So you can go to just about any hardware store and pick up security fixtures like this already with the motion on them. When you're installing fixtures like that, I recommend that they always be controlled by an inside switch, or at least an outdoor switch, because just about every motion head that is made has a little programming inside it. Okay, first off, every motion head has an integral photocell in it, so they don't work during the day. The only time this motion head is going to be activated is when it gets dark out and it doesn't see any more light. And then the motion takes over from there. But, as I said, just about all of these motion heads have some coating in them. So that if you had some sort of switch mechanism, normally you'd probably leave it all on, but let's say it was in the backyard and you were having a party and you wanted the lights on because it was getting a little dark. All you have to do is flip the switch twice, the light comes on, and it'll stay on. Doesn't matter about the motion. You have now overridden the motion head and told that light to stay on. It'll go off automatically when it gets light out and reset itself, or you can then turn it off, leave it off for about 30 minutes, or 30 seconds rather, to a minute. It'll clear itself and you can turn it back on, and now it continues motion. But just that quick double flip of the switch will tell that light, I'm going to stay on until somebody turns me off, either the photocell or again with the switch. Different types of photocells. Again, the type that screw directly into the box. There's another type that has an advantage, and that's what we call a bayonet mount photocell. It can be remote mounted. Obviously, you have to then, run wiring from the photocell to the light fixtures. But the good thing about the remote mount ones is it's very easy to test them. Instead of having the photocell on it, okay, you can take that off and then run a test. This is nothing more than what they call a shunt. It's not a photocell. There's no photocell in here. And you can test your lights. Okay. What I've just now done is turned all my lights on just by this little test cap. That way you can test your lights, during the day, make sure the bulbs are all okay. If somebody complains, well, my lights aren't working, normally it's the bulb. Okay? What happens when either a motion head or a photocell goes bad? Does anybody know? No? Normally, the lights will go on. These are security fixtures. Photocells and motion heads are all rated security fixtures. When they fail, they are designed to fail on. Will they eventually burn out after that and the lights will go out? Yes. But normally you have a period of time from a couple days to a couple weeks where those fixtures will be on all the time, even during the day. If the photocell senses it's going bad, if the motion head senses it's going bad, they just click on. So you'll see your lights on during the day. You can assume then it's either the motion head or the photocell that's controlling them that has gone bad. Back to outlets. Again, by national code, all the outlets have to be GFI protected. Chicago has an additional requirement, especially when you get into holiday lighting, or if you have a small pond in the backyard with a bubbler or an aerator in it or some sort of fountain. All unobserved, in use, outdoor outlets must be protected by an in-use cover. In other words, you're not cutting your grass now, okay, which is temporary, but you have something plugged in 24 hours a day, holiday lighting, a pond, just some, outdoor tree lighting or whatever. In-use cover. What it is, instead of a cover that you have to flip up to use every time, it now has a protective bubble, whether it's plastic or metal. Okay, this one just happens to be plastic. You can see what's plugged in. And then you plug whatever you're plugging into it. The cover flips over that and directs water away from the electric. So if it's If it's in use and not observed, you now must use an in-use cover. Besides GFI protected, you now have an additional requirement of the protective cover. And it just makes sense. The reason I keep talking about grounding in water is, number one, what's the number one rule of construction and or electric, especially outdoor electric, on water? You will never stop water, ever. It will find its way. What we're doing is trying to direct the water away from where we don't want it to go, with gasket seals and hole seals and maybe some silicone caulking, threaded pipe. We don't want water getting in the pipe, okay? You will never stop the water. You just don't want it. You want to direct it away from where you don't want it to get. That's why outdoor fixtures have special designs, special heavy-duty equipment, special materials like brass, or at least heavy plated or aluminum construction, so they don't rust, okay? If you wanted to test your outdoor lighting that is controlled, there are a number of ways to do it. I showed you one way with the remote mount type things where this takes the photocell out of the circuit, and this is just like a switch that turns everything on. Okay, that's one way. You can use more common switches inside to control those outdoor circuits too. Let's say that, again, on motion heads, you can control that light to stay on and off. Well, if you had what is known as an on-off-on switch, or even this three-way, okay, you can, with an on-off-on, you have an off and on in the, or off in the center and on either up or down. One way, it can be going through the photocell or the motion head. If you wanted to turn the circuit off, it goes into the middle. And if you wanted to turn it back on, going around the motion heads or the photocells, direct to the light bulbs now, it obviously requires two switch wires instead of one, okay? You've just taken the photo or motion cell out of the circuit and testing the bulbs direct. So it can be tested right from a special switch also. If in fact you had, let's say, two circuits you wanted to control done by, for lighting, let's say you have circuit for the back and circuit for the front, maybe front lights, and then your back porch lights on a 2 or 3 flat, but you want it all controlled by one switch. If you have two circuits, you can use a 2-pole switch. I've got a circuit going this side, and I've got a circuit going this side. Obviously, I'm going to be turning front and back on at the same time, okay, but this switch can handle 2 separate circuits. If you have a lot of light fixtures and it's too much for one circuit, and you need 2 circuits to control those fixtures, or they're just in 2 separate locations and they're already 2 separate circuits, you can still be controlled with one switch. Are there timers that are 2-pole that can do that? Yes, there are. There are timers that will run 2 circuits. Obviously, again, they're going to switch at the same time, but one timer can run 2 different circuits. There are electronic timers out there that can switch up to 7 circuits with independent times. Now you're getting into some of the programmable electronic timers, and instead of $60, you're up near $200, but they can control different circuits at different times by the programming in the timer itself. When we're dealing with outdoor circuits, I've always done a couple things, and this is where experience counts. Whether you're installing stuff for yourself new, or now you have to effect a repair, you're going to run into the same types of problems. Outdoor wiring will get corroded. Outdoor fixtures or piping will rust unless they're the PVC. Even the heaviest metallic conduit is going to start rusting. When you're installing it, you can help prevent that rust. If you're fixing something and you run into the corrosion and rust, there's ways to clean it up and then fix it again. There are certain things that we use that when I'm installing outdoor fixtures or stuff, I always bring along with me. The first thing for screws is I always use an NIC's compound on the screw threads themselves. Okay. All of these covers are going to have exposed screws. Your light fixture somehow is going to mount with exposed screws. So at a minimum, I will put NIC's compound on those threads before I tighten up the screws. It just prevents the rust from taking hold on the threads. The wiring. Copper wiring exposed to water is going to turn green. Okay, so sooner or later, when you're twisting these connections together and you've got a plain old wire nut on them, they will start to corrode. Sometimes they can corrode so bad that the corrosion can eat all the way through the copper and it just snaps off. Okay, there's a couple ways to prevent that. You'll notice in your handout there's something called outdoor wire nuts. They are filled with silicone to keep the moisture out, to keep the water out. There's also what you use, it's an antioxidant compound, okay? It's like a grease, but not quite. It keeps air out, keeps it also conducts, okay? So once you twist your wires together and you put this stuff on before you put the wire nut on and put the wire nut on, it helps to resist corrosion on that wiring. This is also used where you connect copper and aluminum wiring, because the aluminum can corrode quicker than the copper can. It's very important when you're using aluminum wire to use an antioxidant compound. There's nothing wrong with aluminum wiring, by the way. Okay, a lot of buildings around here still have, especially the high-rises, still have aluminum wiring in them. There's nothing wrong with aluminum wiring that a little prevention won't cure or will cure. Again, we're dealing with oxidation of the aluminum, which acts as a resistor and starts heating up the circuit. Okay, where that aluminum is connected, if it's connected to a brass screw as opposed to a bronze screw, it will start to corrode the aluminum. There are special sockets and special switches that say they are rated for both copper and aluminum. They normally have bronze contacts as opposed to brass. But, again, with a little antioxidant compound, there's nothing wrong with using aluminum wiring, inside or outside. The last being possibly where we have our light bulbs being screwed in. It's a dielectric grease. What that means is this is non-conductive, by the way. I mean, I can smear a bunch of this stuff on a piece of paper and use my multimeter and it will not read anything. But once power is applied to one side, it transmits through the grease to the other side. So in order for this to be electrified, there has to be power applied to it. It is by itself non-conductive. Another little trick that is very common is WD-40. Does anybody know what WD-40 stands for? Water displacement. 40 just means that it was the 40th formula that was working. He went through 39 other formulas before he got to 40. Water displacement. It was normally used in automotive to start with to dry out distributor caps on an automobile. When they got wet inside, moisture inside, your car wouldn't start. And so it was really developed in automotive to start, and then it found its way to just about every other use. So don't be afraid of using WD-40 in an electric socket. Just don't have the circuit on when you're spraying it in. Let it dry out. And now your circuit, it will naturally displace water once the WD-40 is dried out and it's still protecting that socket. So WD-40 works wonders also. All right. The other thing that I've done normally when I'm installing something like this, if I can, I'll take the screws that are given here, and these may be bronze painted. Normally they're chrome plated screws, but I tend to replace them with stainless steel. Okay, I mean, I just go that extra step because I know if I'm going to have to come back and repair something, at least I can get it apart. All right, I don't have to chop something out and then buy all new equipment again in order to repair it. Because I have seen outdoor boxes that were just so badly corroded because of shorting circuits and just a bunch of water in them that literally we've had to cut the boxes out, in order to just repair the circuits. So with a little thinking and a couple pieces of equipment, when you're installing this stuff, it'll last forever out there. And if it has to be repaired, and every light fixture eventually is going to have to be repaired somehow, whether the glass is broken, whether the bulb breaks off inside it, bulbs burn out. A lot of light fixtures you have to disassemble to, unscrew to get to the bulb. If in fact these threads on the aluminum here are coated with the antioxidant compound before you screw it together with the light bulb inside and turn it on, now you'll know that you'll be able to unscrew that thing where corrosion hasn't affected the threads. Remember, these fixtures are designed to shed water. That doesn't mean water doesn't get in them. Okay, it gets into parts of them. But again, they're designed to get the water away. Normally, these fixtures will have a gap down here that if water gets in this box mount, it will drain out. Okay, same thing where the light bulb is. If somehow water gets into the decorative parts, usually it's designed to drain around the socket and out. Okay, that's how they're designed. But doesn't mean water gets in. You will never stop water, ever. You just want to be able to direct it away from where the electric is. Are there any questions so far?
Can we mic that?
You sort of answered it already. I have a fixture like that, and I bought one of those little, I don't know what to call it.
The fluorescent bulbs, or?
Yeah, so that when you enter, it goes on, but it still don't work. And you said sometimes the system burn out and the light keep.
So you have a motion fixture, but it's not working.
Yeah, and I bought that little, for maybe about $8 right from here, and I put it in, and the same thing happened. So evidently, you need a new system altogether.
Well,
I
no,
don't
no.
know.
You said you have a motion. Is it motion or photocell?
I think photo.
Okay. You've screwed a photocell in behind a fixture with glass on it. It's very possible that the glass is affecting the photocell. Some photocells will work like that, others won't. All right, I can't tell you which is which. All right, but I do know that some of these little photocells that you can screw in before the bulb, if it's behind glass, you have a 50-50 chance of it working or not working. All right, it's probably the glass is refracting the sun away from the photocell, or it's taking enough infrared and ultraviolet light out of the sunlight where it's affecting the photocell and it's not working. Glass does filter sun. Okay, so a lot of times these little inexpensive photocells, you think you can screw into a light fixture like this and automatically have it photocelled, it might not work. That's very possible, yes. And if there's any way to tell if it's going to work or not, no. Some glass is heavier than others. Okay, some have actually crystal glass in it, which is an even more effective filter for sunlight. Definitely, probably won't work behind white glass or colored glass, because that's even more of a filter of the sunlight. So yeah, it's very, very true that it's probably the glass is filtering the sun enough for it not to work.
Okay, another question over here.
If you have to recondition one of those boxes, the light fixture, outdoor fixture, can you apply that dielectric grease to it to, if it's rusted a little corroded, or do you have to replace it generally?
Unless it's corroded all the way through, these boxes, number one, aren't going to rust. All right, they're aluminum. Now, if you have a buried box in a wall that rust got to, there's really not much you can do to the rust. As long as the threads are still good, can you spray that box with WD-40 to help displace some of the rust and moisture? Yeah. Can you re-tap the threads with a tap for 632 or 832? Sure. Clean up the threads. Yeah, go back in with anti-seize compound with new screws, by the way, because obviously if the box is rusted or corroded that much, you're going to want new screws anyway. Go in with stainless steel screws, go in with the anti-seize compound, which will protect the now clean threads. If the outdoor box is rusted through or corroded through or somehow had a hole punched in it, you're going to want to replace it, sure. If the threads are that bad that it won't seal anymore, sure, you want to replace the box. That's about it for our outdoor lighting. I'll go one step further. There is a little testing procedure in there. And it gives you, in some of the things, it gives you a basic electric toolkit. The toolkit is going to be the same for indoor or outdoor wiring. They mention the difference between a solenoid tester and a meter. Both are good. You'll notice on the last page of the testing sheet, it'll mention something called phantom voltage, which a solenoid tester will verify, okay, because it needs power behind it to work, whereas on a meter, can you read phantom voltage and not know what it is? Yes, that is true. But a meter will also do one other thing that a solenoid tester can't do, and that will read actual low voltage in the circuit, okay, that has power behind it, but maybe not enough to show off on the solenoid tester. So if you have voltage that is being bled off by something, like wiring underground that is now being exposed to water, okay, not enough to short the circuit out, but it will drain voltage, that can show up on the meter. Okay, so both are good. If you're using only a meter, you have to know how to use it. Again, all of this equipment takes a little knowledge. You don't want to start working on electric without that basic knowledge of what electric can do, okay? Working safe, don't work hot, test the circuits to make sure that the power is off. Don't assume because you flip one breaker that the power is off. Don't assume that the black wire is always hot. I've gone into many locations where I've had the white neutral as the hot wire. Totally wrong, but there it is. So when I open up a box, I test the wiring. Not only do I test the hot wires, I test the neutral wires to make sure that they are in fact neutral.
Yeah, a lot of times you think the white wire is neutral wire, but
You can't assume,
can't assume, right.
okay? I won't go up into what assume means, but you just can't assume that everything is perfect in the way it should be, because a lot of people misunderstood the colors. I hate to say it, but some of the European wiring is different than ours, and some people that have come over from Europe wired things different than we do, and you have to be ready for that, okay? So don't assume that the white wires are always neutral, and don't assume that the green wire is always ground, because some people may be colorblind and they mixed up green and blue. So don't assume, always test.